Alright, so here's some examples of some simulations. We've got a person with type of O blood. 44% of the population has type of O blood. You are trying to find 3 units of type O blood, run at least 10 trials. So, the way we're going to simulate this, I would pause it if you want to try this on your own. One through 44. And then 45 through 00. Okay. We're going to see how many people it takes to find 3 units of type O blood. And by the way, this is 0, 1. Okay. So here we go. There's 1. There's 2, 3. So 1. So we did 1, 2, 3, 4, 5, 6, 7. 7 people. Okay, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it took 10 people. One, two, three, 4, 5. So this trial took 5 people. I'll do one more just so you can see how it's done. 1, 2, 3, 4, 5, 6, 7. So it took 7 people, 10 people, 5 people, and 7 people to find 3 units of type 0 blood. So run 6 more trials on the numbers on the screen, hit pause, and see what your results are. Alright, pretty much same problem as before. You want to find 1 person with type O negative blood. 7% of people have O negative blood, so we're going to use O1 through 07 is O negative, and 08 through 00 is everything else. Okay, we want to keep going until we find 1 person. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There we are. So 18. We do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. Okay, that one took 15. Okay, do one more trial. 1, 2, 3, 4, 5, 6, 7, 8. So you just keep going until you find 1 person that's between 1 and 7. 17. So that one took 19. Okay. Alright, this simulation is a little weird because this would be much easier done on a calculator, because you could simulate numbers 1 through 22, where 1 through 12 are men, and 13 through 22 women. Okay, we're going to pull 3 people. If we pull man number 12, we cannot pull man number 12 again. So let's see what we get. Alright, 16, 13, 9. So that's woman, woman, man. 69, not a candidate. 50, 24. Alright, 18, 2, and 3. So we got woman, man, man. So 35, 72, 35, 7. There's man. 57, 94. Here's a 7. We already used man number 7 though, so that doesn't count. 14 is a woman. And 8 is a man. So 2 men. I'll run the simulation one more time. 43, 56, 62, 78, 37, 83. Okay, there's man 7 again. But it's a different trial, so we can do this. There's 8 and 10. So we got 3 men that time. So we had 2 women, 1 woman, 1 woman, no women. And then you're just going to keep doing this 10 times until you get your data. Alright, on average, suppose a baseball player gets 3 hits every 10 times at bat, and he gets exactly 3 at bats every game. I'm going to do 50 trials, which is crazy, but I'll demonstrate how to do it. So 1 through 3 is a hit. 4 through 9, including 0, that'll be 10. No hit. And you get 3 at-bats in a game. So if I pair them off into groups of 3, so 1 through 3 is a hit. So we got 0 hits, 0, 1, 0, 0, 0, 2, 1, 0, 1, 0, 2, 0, 2. So I did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14 trials already. And we had 1, 2, 3, 4, 5, 6, 7, 8, 9. So we had 9 hits, 14 trials, and each trial represents a game. So So in my 14 trials, I ended up with 9 hits, which is an average of 0.64 hits per game. Okay, here's a unique simulation because we're talking about a carton of eggs, which is 12 eggs, and then a shipment, which is 3 cartons. Each egg has a probability of 5% of being broken. A broken egg in any carton makes it a bad carton. What is the probability that a shipment of 3 cartons will contain no bad ones, 1 bad one, 2 bad ones? Conduct 10 trials. So we're going to say 1 through 5, or actually 0, 1 through 0, 5 is a broken egg. And 0, 6 through 99 and 00 is a good egg. Okay, so we're going to simulate a carton at a time, and then we're going to do 3 cartons per shipment, and that will be 1 trial. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 1 carton. And I'm looking for a 1 through 5. I got an 8, I got a 7. Okay, so those are all good. So that's a good shipment. Then we got 2, 3, 4. Okay, here's a bad egg. So that shipment's bad. Okay, there's no 1 through 5, so those are all good. So out of this shipment, there were 2 good cartons and 1 bad carton. So then I'd start again. That's 1 trial. Okay, here's a 1, so that's a bad carton. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's a 3, so that's a bad carton. 4, 5, 6, 7, 8, 9, 10, 11, 12. And those are all good. So this shipment had 1 good carton. So we had the first shipment had 2 good cartons. The second shipment had 1 good carton. That's 2 trials. So I need to do 8 more. So you can do that and check out your data. Alright, this last simulation, we're talking about a basketball team, 12 players. Coach wants to pick 5 starters at random. How often would Himmelfarb and Joel be on the same team? So we'll say that 1, 01 is Himmel. 02 is Joel. And then 03 through 12 is everyone else. Now, again, this is an easier one done with a calculator because you don't have to worry about all the other numbers. So anything 13 through 99 or 00, ignore. And we're looking at how often does 1 and 2 appear on the lineup. So ignore, ignore, ignore. Okay, there's 1. We already have a 5. Oh, this is brutal. Cut it off. 8, 89, You already got a 5, 00. Alright, there's 6. Okay, there's Himmel. We got 3 people on the team so far. There's 10. And player 12. Alright, so there's my 5 players. Like I said, calculator would be much easier. You can do the random int. And you can actually put a comma 3 in there, and it will give you 3 numbers. The key is you just can't do, you can't repeat the same number because that player is already on the field. For a TI 89, you just do random 12, and I believe that gives you numbers between 1 and 12. You may have to do int. But there was 6 simulations.